Hello, welcome to the Open Education Resource OER on Microprocessor 8085 instruction set. Links of this OER for various resources created like video quiz, evaluation strategy, contact through email are available on the website developed as shown in this slide. Learning objectives of this video are define machine language, define assembly language and need of assembler, define categories of 8085 instructions, identify opcode and operand of instruction, identify registers used in 8085 instructions, identify valid pairs of 8085 registers used in instructions. Evaluation strategy. Different types of questions can be asked to evaluate this, and marking scheme is also shown. Now these different questions will be placed in the URL shown in slide 2. Introduction. Now microprocessor, microcontroller or DSP is a hardware, digital hardware, which executes the instruction given by user's program. User's program resides in the memory of the system. Instructions should be in a language known to the microprocessor. Microprocessor understands the language of zeros and ones only because it is a digital hardware. This language is called machine language. Now, assembler is required to convert assembly language program into machine language code, because microprocessor can understand only machine language. It cannot understand assembly language. Instruction. So instruction of a program is nothing but a group of binary bits with special meaning and designed as per architecture of microprocessor, microcontroller or DSP to perform a specific function or operation. 8085 microprocessor has 246 instructions. Instruction consists of opcode and operand. Opcode is operational code or command by which microprocessor decides which operation should be done. Now, operand is either data or an address on which the operation decided by opcode is performed. The length of the data or an address is of either 8 or 16 bit. Two examples are given: move A, B, MVI A, 32x. So in the first instruction, content of register B will be transferred to the accumulator, means content of both B and A will be same at the end of the execution. In the second instruction, content 32x, that is known as 8-bit data, will be loaded into register A when the instruction is executed. 8085 instruction category. Now, as per how many number of bytes are occupied in memory, there are three different instruction category. One is 1 byte instruction, means it occupies only 1 byte in the memory. So opcode and operand are in the same byte. 2 byte instructions, that means it occupies 2 bytes in memory. One instruction occupies 2 bytes. The first byte is opcode and second byte may be 8-bit data or 8-bit address. 3 byte instruction, it means it occupies 3 bytes in memory. One instruction occupies 3 bytes in memory. First byte is always opcode, second byte is either 8-bit data. Okay, now sorry, here it is 16-bit data or 16-bit address. Register structure and memory. So here, these are the registers of 8085 microprocessors. They can be used in pair, that means B and C, T and E, H and L. But we cannot use D and L as a pair. We cannot use B and E as a pair. And these are the 16-bit registers. Now here it is program memory. So and here it is data memory. So in a program we require instructions and data as well as. Now 8085 has 16-bit address bus, so total address space is 00000 to FFFF hex. Now there is no separation of program memory and data memory. All are residing in the same space. That means 0000 hex to FFFF hex. This total address range is used for program memory and data memory. Instruction format 1 byte. So here tasks is defined, opcode is defined, operand. Now this standard conventions are defined. RD, RS. What is the meaning of RD, RS is also shown. What is the meaning of R? It is also shown, and which task will be performed, it is also shown. For example, in move RD, RS, if I keep RS as A and RD as B, then it is move B, A. So as shown, the content of B will be transferred to content of A. That means content of both will be same at the end of the execution of the instructions. So these different instructions will be discussed in the next videos. Instruction format of 2 byte. That means here task type is defined, tasks is defined in detail, opcode is the first byte, operand is the second byte. It may be 8-bit data or 8-bit address. And what happens is shown here. The conventions are explained here. The different actual instructions will be discussed in next videos. Instruction format 3 bytes. So task type is defined. Okay. The first byte is always opcode. Second and third bytes are either 8-bit or 16-bit data or 16-bit address. And it is shown here. Now instruction set classification. So according to the type of operation we are doing, it is data transfer instructions, arithmetic instructions, logical instructions, branching instructions, control instructions. So in the subsequent videos, major instructions of all these different classification will be discussed.